Health authorities and maritime security units are currently responding to reports of a significant biological hazard involving a cruise vessel arriving at port. The presence of specialized hazardous materials teams highlights the gravity of the situation, which centers on a reported outbreak of hantavirus among those on board. This development has triggered immediate public health protocols designed to contain highly infectious zoonotic diseases. To understand the scale of this response, it is necessary to examine the nature of hantavirus itself. Hantaviruses represent a family of viruses spread mainly by rodents. In the context of a maritime environment where storage areas and tight living quarters are common, the potential for rodent-borne transmission becomes a critical focus for epidemiologists. While often associated with rural or wilderness settings, the introduction of the virus into a confined, high-occupancy setting like a cruise ship presents unique challenges for surveillance and containment. Public health officials prioritize these cases because of the severe clinical outcomes associated with hantavirus infections, which typically manifest in two distinct forms depending on the specific viral strain involved. The first is Hantavirus Pulmonary Syndrome, or HPS, a severe and sometimes fatal respiratory disease. The second is hemorrhagic fever with Renal syndrome, which affects kidney function and can cause systemic bleeding. Because the virus is primarily transmitted through the inhalation of aerosolized particles from rodent urine, droppings, or saliva, the ventilation systems and cargo holds of large vessels are of particular interest to investigators. The arrival of hazmat units suggests that officials are treating the environment of the ship as a contaminated zone, necessitating rigorous disinfection and the isolation of symptomatic individuals. This level of framing is standard for pathogens with high mortality rates, ensuring that the local community and port workers are shielded from potential exposure. As the vessel docks, the immediate priority remains the assessment of the infected and the stabilization of the environment to prevent any further leap from the rodent reservoir to the human population. The operational response at the port involves a multi-agency coordination effort, typical for incidents involving international travel and potential biohazards. Hazmat units are tasked with establishing an essential corridor between the vessel and medical transport vehicles. According to standard operating procedures for maritime health emergencies, the ship's master is required to submit a maritime declaration of health, detailing any illnesses or deaths on board. In this instance, the reporting of hantavirus cases has moved the situation from a routine medical clearance to a high-priority quarantine event. Clinical management of the affected individuals is currently the primary focus for on-site medical teams. Once passengers or crew members are evacuated, they are typically moved to specialized isolation wards within regional hospitals, capable of handling biosafety level 3 or 4 pathogens if necessary. Laboratory confirmation is a complex process. Diagnostic testing for hantavirus usually involves detecting specific antibodies, IgM and IgG, or utilizing polymerase chain reaction, known as PCR, to identify the viral RNA in blood or tissue samples. These tests are conducted in high-security labs to ensure that the virus does not escape into the general population. While the source material focuses on the visible presence of hazmat units, the invisible work of the laboratory is where the definitive scope of the outbreak will be determined. There is often a significant contrast between initial claims of a stricken ship and the verified data that emerges after the first 48 hours of testing. Health agencies must also investigate the logistics of the ship's recent itinerary. They look for ports of call where the vessel may have taken on supplies or where rodents could have boarded, such as tropical regions or areas with high agricultural activity. The presence of rodents on large ships is a historical challenge in maritime history, but modern surveillance relies on integrated pest management to prevent such occurrences. If these systems fail, as the current situation might suggest, a full-scale forensic audit of the ship's sanitation records will be required. Officials have not yet released specific numbers regarding the total count of those infected, but the scale of the portside response indicates that they are taking no chances with the possibility of secondary transmission, despite it being a rare occurrence in most hantavirus strains. Prevention and long-term surveillance remain the most effective tools in managing hantavirus risk worldwide. Public health guidance generally emphasizes that the most significant risk factor for hantavirus infection is rodent infestation in and around human living spaces. In a residential or commercial context, this involves sealing gaps and holes in buildings, using traps, and ensuring that food sources are inaccessible to mice and rats. For travellers and those in the maritime industry, the focus shifts to rigorous cargo inspections and the maintenance of dry, clean storage environments. When cleaning areas suspected of rodent activity, officials strictly advise against sweeping or vacuuming, which can kick up the dangerous aerosolized particles. Instead, the use of disinfectants and wet cleaning methods is mandatory. The limits of current medical knowledge regarding hantavirus are also a factor in the current uncertainty. There is currently no specific vaccine or cure for hantavirus infection in humans. Treatment is largely supportive, involving intensive care and, in severe cases, mechanical ventilation or extracorporeal membrane oxygenation. This lack of a targeted pharmaceutical intervention is why the rapid deployment of hazmat units and strict quarantine measures is seen as the only viable way to manage an outbreak. Surveillance teams will likely continue to monitor the port and the vessel for several weeks, as the incubation period for hantavirus can range from 1 to 8 weeks, making it difficult to immediately identify every exposed individual. As the investigation continues, authorities urge the public to remain calm, noting that hantavirus does not typically spread from person to person like the flu or other common respiratory viruses. The exception is the Andes virus in South America, but such cases are rare and geographically localized. For now, the focus remains on the containment of the specific vessel and the recovery of those already ill. Public health agencies will provide updates as lab results are finalized and the environmental sweep of the ship is completed. For more updates on global health reporting and breaking news, consider subscribing to this channel. The operational scale of the response at the harbour reflects the rigorous protocols established for managing high-consequence pathogens in international transit. When a vessel is designated as having a potential biohazard, specifically hantavirus, multiple layers of government and health agencies are immediately activated. The core development involves the coordination between maritime security, local port authorities, and national public health departments. Upon the ship's approach, the primary legal and medical document utilised is the Maritime Declaration of Health. This document, required under international health regulations, must be submitted by the ship's master to report any cases of illness or death on board that could suggest an infectious disease. In this specific incident, the identification of hantavirus has moved the response from a standard medical inquiry to a full-scale containment operation involving the physical isolation of the vessel. The arrival of hazardous materials units signifies the transition to the clinical phase of the event. Specialized hazmat teams are responsible for the safe extraction of symptomatic individuals, utilizing negative pressure transport systems to ensure that no aerosolized particles, the primary mode of hantavirus transmission, are released into the surrounding port environment. Once removed from the vessel, patients are typically transferred to regional hospitals equipped with dedicated biocontainment or isolation wards. These facilities are designed with high-efficiency particulate air, or HEPA, filtration and strict access controls to prevent hospital-acquired infections. Within these clinical settings, medical staff focus on stabilizing respiratory function. As hantavirus can lead to rapid pulmonary distress, the diagnostic process is a critical bottleneck in these developments. While a ship may be described as stricken in initial reports, medical verification relies entirely on specialized laboratory testing. Hantavirus is not easily identified through routine clinical observation because its early symptoms often mimic common influenza or other febrile illnesses. Laboratory technicians must conduct serological assays to detect the presence of specific antibodies. Specifically, they look for immunoglobulin M, or IgM, which indicates a recent or active infection, and immunoglobulin G, or IgG, which shows a history of exposure. Furthermore, the use of polymerase chain reaction, or PCR testing, allows for the detection of the viral genome in the patient's blood or tissue samples. Because the virus is highly infectious in aerosolized form, these samples must be handled in high-security laboratories, often designated as biosafety level 3. where technicians wear specialized protective gear and work within primary containment devices to prevent accidental exposure. From a logistics and shipping perspective, the presence of the virus on a large vessel triggers an immediate investigation into the ship's sanitation and pest control history. Epidemiologists must examine the ship's logs to determine when and where rodent ingress may have occurred. This involves analysing the cargo taken on at previous ports of call, the integrity of food storage areas, and the efficiency of the ship's integrated pest management program. If rodents, the natural reservoirs for hantaviruses, have established a population within the ship's structure, the risk to passengers and crew increases significantly. The virus is shed in the urine, droppings, and saliva of infected rodents. When these materials dry and are disturbed, they can become airborne. In the confined environment of a cruise ship, the ventilation system becomes a major point of concern for health inspectors, as it could potentially distribute contaminated particles across multiple decks and cabins. The current situation highlights the tension between the speed of early reports and the deliberate pace of official verification. While the visual presence of hazmat units suggests an immediate crisis, the verified data regarding the number of confirmed infections and the specific strain of the virus can take days to materialise. Officials often remain cautious in their statements during the early hours of an investigation to avoid spreading misinformation, as the consequences for the travel and shipping industries are substantial. The quarantine of a large vessel involves not only the passengers, but also the complex web of supply chains that move goods through international ports. Until the ship is thoroughly decontaminated and the threat is neutralized, the port area remains a high security zone, with every movement monitored to ensure that this zoonotic incident does not expand into a broader public health challenge. The management of hantavirus risks on a global scale relies heavily on the bridge between rigorous environmental surveillance and public adherence to established safety protocols. At the core of prevention is the understanding that hantavirus is not a disease of human-to-human origin in the vast majority of cases, but rather a consequence of zoonotic spillover. Public health agencies, such as the Centers for Disease Control and Prevention and the World Health Organization, emphasize that the most effective way to prevent infection is to eliminate the interface between humans and rodent reservoirs. In practical terms, this involves a strategy known as rodent-proofing. For residential, commercial, and maritime structures, this requires sealing every entry point larger than 1/4 of an inch, as small rodents like deer mice or rice rats can compress their bodies to fit through remarkably narrow gaps. Officials also stress the importance of eliminating food sources and nesting materials that attract these carriers. In a shipping or cruise ship context, this places a heavy burden of responsibility on integrated pest management teams to ensure that cargo holds, galleys, and storage lockers remain inhospitable to wildlife. Guidance for cleaning potentially contaminated areas is perhaps the most critical practical takeaway for the public. Because the virus is transmitted through the inhalation of aerosolized particles from dried rodent urine, droppings, or nesting materials, the act of sweeping or vacuuming is strictly prohibited by health authorities. These actions stir up the dust, allowing the virus to enter the respiratory tract of anyone nearby. Instead, the standard protocol involves a wet cleaning method. This requires the use of a disinfectant, typically a solution of 1 part bleach to 9 parts water, which must be sprayed onto the affected area and allowed to soak for at least 5 minutes before being wiped up with paper towels or rags. This process effectively deactivates the virus's lipid envelope, rendering it harmless. For professionals working in high-risk environments, such as the hazmat team seen at the port, the use of N95 or higher-rated respirators, gloves, and protective eyewear is mandatory to prevent accidental exposure during the decontamination process. Surveillance of hantavirus remains a complex challenge due to the significant incubation period, which can range from 1 week to as long as 2 months after the initial exposure. This delay means that public health officials must often reconstruct a patient's movements over several weeks to identify the point of origin. Furthermore, environmental surveillance involves monitoring the population density and infection rates of local rodent species. Changes in climate, such as heavy rainfall followed by periods of drought, can lead to mast years, where an abundance of food causes rodent populations to surge, subsequently increasing the risk of human exposure. This One Health approach, recognizing that human health is inextricably linked to the health of animals and the environment, is the cornerstone of modern epidemiology in tracking such outbreaks, despite the intensity of the response seen at the port. There are honest limits to current medical science regarding hantavirus. There is no specific vaccine currently approved for use in many regions, including the United States, nor is there a dedicated antiviral medication that has proven universally effective. Treatment remains primarily supportive, focusing on the management of oxygen levels and blood pressure in an intensive care setting. This lack of a pharmaceutical silver bullet underscores why the visual of hazmat units and strict quarantine measures is necessary. When a disease has a high mortality rate and limited treatment options, containment is the only definitive tool available to authorities, ethically. The reporting of such events requires a balance between transparency and the avoidance of public panic. While the sight of specialized biohazard units is naturally alarming, health officials maintain that for the general public not in direct contact with rodent-infested areas, the risk of infection remains extremely low. The goal of the current port operation is not only to treat those currently ill, but to ensure that the chain of transmission is broken before the vessel is cleared for further service. As the investigation into the specific origins of this outbreak continues, the public is encouraged to maintain standard sanitation practices and report any unusual clusters of respiratory illness to local health departments. This commitment to vigilance, combined with a grounded understanding of the science, provides the most stable path forward in managing emerging biological threats. For more in-depth reporting on global health developments and public safety, consider subscribing to this channel.